Hello everyone, today I plan to show our planetary escape game. Then, the game introduction. Our game is a planetary escape game. Player can collect some stuff from the planetary, then use that to escape the planetary. Next, this is our group member and position and responsibility, and we use the Blender and Unity to develop our game. Then this is our team member. This is next video will show the game functions.
Hi everyone, today I will show our group work Planetary Escape game. In the game, player need collect several items to unlock the door to escape from room. So I will show some functions we have achieved. Firstly, let's start the game. We have see a menu that has 3 buttons. It's new, load, and quit. Cause we don't have any record, so let's start a new game. In the games, we can press I to open and close the inventory. So let's find the item. Use right click to pick up item. Then in the inventory, we can also use right click to see the item information. Yeah. Let's click all three items. Pick up. Pick up. So now we can see we have 3 items in our inventory. Then also use right click. This will become 1. So that's completed this item. We can see how several numbers at here. You see several numbers, we can open the final door. Also have a key at here. We also can pick up this key. Also, this has something. Use this key to open the door. Right click. Yeah, see, the door disappear. So we can go to the upstairs and see. This is we have finished. In the next part, we will have a door here. Then use this item password to open this door and to finish this game. So that also in this button, right click, we can save the changes and save and then load. You can see we record the position and the items. So that's all. Let's quit the game.
Okay, for next, I will show the functionality.
Hi, I'm Jing. Now I'm going to introduce the functionalities which were developed in Sprint 1. In Sprint 0, we already planned 12 functionalities for the whole project. We marked the size and the priority for each of user stories. In Sprint 1, we chose 6 first priority user stories. The first one is movement. The player can control the movement in the game by using arrow keys. The second one is menu. The player can return to the main menu by clicking the menu button. This function is related to the saving game. The third one is inventory. Inventory contains all the items which is picked up from the room, and those items can help player to escape the room. The fourth functionality is information display. This functionality can display the details of the items in the inventory, and those information can help player to solve the puzzles. The fifth one is interaction with the puzzle. For example, the player can find the key which can unblock the door, and the player can escape the room. The last one is saving part. In Sprint 1, we can only save the position, and we will develop more about saving items in the inventory for next sprint. We can see that we already finished 5 user stories in sprint 1 and 1 left for next sprint, and there are 6 more user stories are waiting for developed, and we will develop these 6 user story in sprint 2.
Hi everyone, this is our burn down chart. A burn down chart is a graphical representation that shows how much work our team has left in the current iteration of Sprint 1. At the start of an iteration, our team estimated the work for all the sprints we choose. The sum of all the hours estimated for all the tasks is the starting point for the graph. So as you can see, on the chart, the y-axis, the starting point is at 154 story points, and on the x-axis it's the sprint days, and we have chosen 30 sprint days, so there's 30 sprint days in sprint 1. Every day we work together on task, and work should reduce every day. Initially, a graph should display a steady downwards trend, but as you can see, this was not the case for our graph. From day 0 to 6, we have a 24-point decrease. This was because our user stories was allocated to our team members, and we were at a learning stages of developing and researching the user stories. This was also where we were highly productive. From day 6 to 10, here, there was a 13 points decrease. This was due to a user story 5. We have initially gave the user story 5 a 55-point degree, but as we were researching more into it, we have realized that this was not as hard as we thought to be, or not as hard as we expected it to be, and we could quickly learn it by using some resources. From day 10 to day 12 here, we didn't have a lot of progress. This was due to a team member working on Blender for the environment, and also another team member working on making the menu, which was needed to finish off user story 6. From days 14 to 18 was our highest steep. In just 14 days, we have finished 22 points decrease. This was due to user story 1 being finished, and also the environmental model being finished by one of our team member. This enabled that team member to join us back into our team and able to help us on other user stories as well. From 18 to 22, from 18 to 22, we didn't have much progress at all. This was due to other obligations and tests. From 22 to 28 here, we had a little bit of progress here due to our user story 3 being completed, and user story 6 also being completed. And from 28 to 30, we just had a user story number 2 being completed in just one day. So this was due to the team member not having a lot of progress early on, and they were able to finish it fast towards the end. And at the end of the 30 days, initially the graph should come down to 0, but we still have 20 points story points remaining. This was also due to the save the game options not able to work as expected. So we are going to put the user story number 5 back into the product backlog, and as a group we'll be able to use it for sprint 2.
Reflecting on Sprint 1, there were tasks that were more difficult to finish than we had originally anticipated. Firstly, even though all the functionalities described in the storyboards for Sprint 1 were finished, they had took a lot more time than some of us had originally anticipated. This meant that we weren't able to apply them to all of the game objects we had intended to have in the final version of the game application. This has caused us to push the task to do so to Sprint 2. We should, however, be able to quickly finish it, as extending the functionalities to the other game objects should be simple copy and paste tasks. There is also a bug where some of the game models we imported from Blender have missing faces, whilst others are inverted on them. The task of fixing this has also been pushed to Sprint 2. Another important thing that we realized was the unit tests were not as easy to implement as we had initially thought. This was because the inbuilt game engine classes that we had used to complete the storyboard functionalities, as far as we know, did not allow us to see its underlying algorithms. This forced us to predominantly use black box method for our unit tests, many of which could only be done manually as they required hardware inputs.